welcome to day 9 of mobile application development. We will make our way through chapter 5, at least farther through. So we talked about buttons last time. There are 3 types of buttons: the text button, the shape button, and the image button. And we looked into how to implement those, what the syntax was, and what the approach using drawn to code was. Briefly, the text button is just text, typically displayed in a light blue color. The shape button has the same text, but also has a drawn shape of some sort behind it, either a rectangle or a rounded rectangle or something else. And the image button uses 2 or more images of your own design to create button in whatever style or effect you care to have it. All right, so we stopped here at the ... syntax. So when working with Lua tables, Corona tables, or Solr 2D tables, like buttons are, or display tables, which are typically, I refer to all of these as objects, as do people online. Strictly speaking, under the hood, they're Lua tables, but they use a very familiar syntax, which is using periods to indicate where something is, where a resource is that you're trying to reach, or a function is that you're trying to execute. We'll use this a lot. Just as a brief example, if you were trying to access a variable called Nemo, the address might be ocean.reef.anemone.nemo. Each of these dots moves you closer to finding the resource that you're looking for, unless, of course, he's missing. All right, as an initial example, something we've already done a few times is using a dot to change an attribute on an object that exists. So if we had an attribute object 1, and we wanted to change it, we needed to change it, we could address it using the dot syntax and reach into it to change any attribute that's built in. So for instance, you can change the XY attributes of an object that's on screen, so to move it to a new XY location. If it has a text component, you could change the text value using .text. We've also used .isVisible to toggle whether something is on screen or is not on screen. So your dot is the key to accessing these attributes. In drawn to code, you can use either a snippet to do this or a set attribute action. So let's take a look at the set attribute action. So in drawn to code, there is a set attribute script object. It's in the actions palette. So to use set attribute, you first have to select a target object that you wish to modify. And then based on what that target object is, you'll get a settings panel with available modifications. Like the transition script object we looked at last time or the time before, you'll need to make the adjustments you want in the settings panel and then check the checkbox next to the setting that you want the set attribute to modify. So for example, if you had a text display object and you wanted to make changes to it using set attribute, here's the settings panel that you would see. So you've got access to XY, width, height, text, alpha, text color to easily modify, and then to place that set attribute script object in your stack wherever you need it. That is, where you want the change to occur or when you want the change to occur. All right, the other part of this chapter is logic. So we've covered the UI element, the button, in a fair amount of detail. Now we're going to look into if-then logic in more detail. And a running example is, let's say that we wanted to implement a fancier button, a button that made a sound when the user clicks it, which is not hard. We've already done sounds. You guys have implemented sounds. We've loaded sounds. We've played sounds. So if you just wanted a simple button that played a sound when it was pressed, you would load a sound and then you would put a play sound attribute or play sound object, script object, into the event handling function for that button. And in that manner, when the user clicks the button, you would get the play sound making the sound. But let's say we want something a little bit more interesting, a little more involved, a little more sophisticated. So we want a sound when the user presses down on the button, but then we want a separate sound when the user releases the button. So a click sound and a release sound. So that's not terribly tough to do. There are at least 2 ways to do it. You could, of course, have two event handlers. You could have an on-press handler and an on-release handler. That would work great. But if you wanted to do something with the least amount of code, you would hook the button up to the on-event listener, and inside the on-event handler, you would detect the phase of the event. So as a reminder, buttons have three different events: the began, the moved, and the ended phases. Moved is not something we normally do anything with because we don't normally let the user move buttons around the screen, but you certainly could. If we're using on event, we normally focus on the began phase and on the ended phase. So logically, to build the Boolean structure that will enact this logic, it's going to look something like this flowchart. This would represent the logic that's inside of the on-event handler function. So you would ask the event what its phase was by using the dot syntax. You would say something along the lines of if event.phase double equals began, then we're going to do, let's say, the click sound. If it's not began, then we're going to test to see if it's ended. So if event.phase double equals ended, then we'll play the release sound. Otherwise, we won't play any sound. So if the phase is not began or ended, no sound should play. So the Lua syntax for if statements is really fairly clean. There's the keyword if, then, else, else if, and end. And you're going to place the Boolean condition, the Boolean test, between the if and the then, or between the else and the then, or between the else if and the then. And then at the end of the if statement, you will end it using the keyword end. So it starts with if, it ends with end, and in between, you depict your logic using these keywords. You place the code that you want to execute for a true condition in between the then and the next keyword. So in this structure is an if, else if statement. So we would write it in the form of if condition 1, then do something for condition 1. Else if condition 2, then, well, you do something then for condition 2. This structure works great if you have a situation where only one of these two conditions can be true. If it were possible that both were true, then this would not be the right logical statement to use, because as soon as a true condition is found in an if statement and the code executed for it, then the if statement is done. So for instance, if condition 1 was true in this type of logical statement, then condition 2 would never be tested. If condition 1 was true, then the code associated with condition 1, the do something, would be executed, and then you would end the if statement. So condition 2 would never be tested. So if you had a situation where you wanted to respond to condition 1 if it was true, but then you also wanted to respond to condition 2 if it was true, then you wouldn't want to use this if, else if structure. You would want to use two consecutive if statements. In any case, for our needs here, the phase cannot be both began and ended. So you're guaranteed that either condition 1 or condition 2 is true, and it's not possible that they both could be true. All right, so to flesh it out with actual Lua code, then you would write it something like this: if event.phase double equals began, then audio.play click sound. Else if event.phase double equals ended, then play release sound end. So note a couple things. First off, we're using the double equals operator, which is the equality operator. If you used a single equal sign in these tests, here and here, this would not work and it would not run. The single equal sign is used only for assignment. That is putting data, putting a value into a variable. The double equal sign is the test for equality. So double equal signs asks in Boolean language whether what is on the left is equal to what is on the right. So it asks, in this case, whether the event.phase is began or ended. The word event here is not a keyword, importantly. The word event, which is pretty standard to use in Lua and Solr 2D, is given by the method, the way the method is written, by the way the parameter in between the parentheses is written when the method is defined. So Draw-No-Code always calls it event. When I refer to it as event, that's where it comes from. But this is not a keyword. It could be named something different depending on what your needs are at the time. All right. How would we do this in Draw No Code? Draw No Code by default uses onPress. OnPress means that you don't have to worry about the phase, because typically we're only interested in when you press a button, not if you move it, not if you release it. However, in this case, we're trying to write some logic that will involve the press and the release phases, and the onPress event will not tell you about onRelease. You need to use onEvent to get to that data to use the if statement that we want to use. As I noted a few slides ago, you could use a combination of two listeners, onPress and onRelease, which should be super easy. And one of the downloads for the chapter resources in this chapter does it that way. But if we want to use the if-then logic, because we're in a chapter where we're talking about and thinking about if-then logic, then we'll want to use a single listener onEvent. So how do we do that in Draw No Code? Because when you create a button, you will get the onPress listener and an event handler for the onPress event. So the technique is actually pretty straightforward. You'll just add the onEvent listener. There's an add listener button in the settings panel for the button. So you'd add the onEvent listener, and then you'd remove the onPress listener. That would leave you with an extra event handler. So if you look at the stack, the screenshot of the stack down here, you'll see this is what it would look like after you're done. The button object 1 is connected to the onEvent listener and is attached to the object 1 onEvent handler function. The older object 1 onPress handler has been deleted. If you didn't delete it, you'd have a function which was not connected to a listener and would never be called. It wouldn't stop your stack from running. It wouldn't generate an invalid main.lua, but it would have more code in it than could run, which is bad form. So we're moving ahead with this consideration of how would we get this separate press and release sound button to work, especially in Draw No Code, since that's what pretty much everybody's using. So the first challenge was, well, wait a minute, how do we switch from onPress to onEvent? And we just covered that, but then we've got a second challenge, which is kind of what makes this a good example. Draw No Code doesn't have logical script objects. There is no if-then script object that you can add at this point. So then what do we do? Am I saying that you can't do logic in Draw No Code? And if that was the case, it would be worthless. So obviously you can. It just requires the use of a technique. So I've got the two techniques listed down here that I talk about in the book, which is convert to snippets or surround with snippets. So let's step back just briefly. To make this work, you'll need the sounds. Otherwise, there's nothing to put inside the if-then logic. So if you're trying to follow along, you'll need to load the two sounds. So you'll see in my stack there, I've got object 7 and object 8 are both load sounds. So I'm loading click on and click off. Click on and click off are sound resources that are in the chapter downloads, so feel free to load them and use them. As with images, when you load it, if you've already saved your design, Draw No Code will offer to copy the sound resources into your project folder. If you haven't saved your design, then Draw No Code doesn't know what the project folder is and wouldn't know where to copy it. So if you'll load those two sounds, and you can see I've loaded them and I've moved them up towards the top of my stack here. That is not a requirement, but it's just for me, it's a matter of habit to have everything that I load up towards the top of the code so I can see it clearly. And then it does make at least some sort of intuitive sense that you would want to load it before you play it. But of course, these play sounds are inside of a function, so they won't get called until the function's called. So strictly speaking, you do not have to have object 7 and object 8 up above these in the stack, because in terms of flow of execution, no matter if they're below or above it, they'll be loaded first. Once you have the load sounds, then you can create two play sound objects. So you can see I've created object 9 play sound and object 10 play sound, and they play each of the sounds. And then I've moved them into the event handler using the move resource into function button in the settings panel. And that leaves me with a stack that looks like this screenshot. And so it may look like, okay, maybe that'll just work somehow, but it won't. what it would do now if we played it would be when you pressed the button, both sounds would play. And when you release the button, both sounds would play. And if you accidentally moved your finger while you were pressing the button, both sounds would play repeatedly. So that's kind of fun, makes a fun sound. But why is that? That's the case because we don't have the logical structure in there. We don't have the if-else-if statement that will choose which sound to play. So bottom line is what we want to do is write some code that will choose automatically, programmatically, which sound should be played. On the press, we'll play click on the release, we'll play click off. So how do we get that logic in there? Two approaches. Convert the play sound script objects 9 and 10, into snippets, and then you'll have actual code that you can edit inside the snippets, or copy and paste the snippets to merge them together into one snippet. That would work as well. Or approach 2 would be to surround the play sound script objects 9 and object 10, with snippets that contain the logic. So those both work fine. So then you might wonder, well, how do I choose? Well, we'll have examples of using each approach throughout the semester. Obviously there's a lot of logic in programming, although this is maybe our first real talked through step-by-step example. There'll be several more. So I'm going to start out with the surround with snippets option 2. So to do that, I have a stack that has these two play sound objects, but I need all this if-else-if syntax in there. So I break the if-else-if syntax into 3 separate snippets. So you see here I've got the if snippet, which tests to see whether the phases began. I've got the else-if test here, which tests if the phase is ended. And then I've got the final end keyword to close the if statement. So that's all the logical code that I need in my stack to implement the logic that we need. And the key is just to put those in the right place. So I'll put that first snippet before the click on sound. I'll put the else if logic after that and before the click off sound. And I'll put the end right after the click off sound, play audio script object. That will leave me with a stack that looks like this. So this is the same stack we just saw, except the play sound object 7 and the play sound object 8, you can see that they're sandwiched in between 3 snippet objects, object 6, object 11, and object 12. And I've named the snippets kind of a shorthand version of what the code in them does. So this is called if began then, this is called else if ended then, and then finally ending the if statement. So let's hop over to drawing a code and do this if you want to follow along and see how it works. So this is a button program. We need a button script object, so that'll be in the widgets palette. You can pick the style of button that you want. I'm going to use a shape button because that means I don't have to hunt down 2 images. And I'll make it look a little nicer and make it say something a little bit more descriptive, like play sounds. So this would create an app with a button, and when you press it, it would run. Bust the stack out so that I can zoom in so that you guys can maybe read it. All right, here's the stack. So there's the shape button, object 1. Here's the object 1 on press handler and the default snippet inside of that. If we look at the code, we can also see that the code that's generated here is using the onPress listener to call this object 1 onPress handler. That's the connection between the button and the event handling function, and the connection is triggered when the user presses the button. But like I said, that's not what we want. What we want is one event handler into which we can put our if-then logic to branch the flow of execution between event.phase begin and event.phase ended. And onPress is not going to do that for us. So it does not matter the order that you do this, but we're going to add the onEvent listener. So press the Add Listener button and choose onEvent. and click OK. And DrawNaCode's giving you a little warning here that says you've got two listeners that overlap because onEvent contains onPress as well. So you're leaving Solr2Do in an awkward situation, which was when the user presses which one of these event handlers do I run, and if I run both, then I double everything I need to do. So this is just one of the few attention warnings I've put into DrawNaCode just to let you know that this is a situation that needs to be thought through a little bit better. But I'm going to say yes, we want to continue because I know I'm going to remove the other listener in the next step. So yes. My stack now looks like this. I've got the same button, object 1, but now I've got two event handlers. I now want to remove the onPress handler. So I hit the remove listener button, and then I get a dialog with a choice of the attached listeners, and the one I want to remove is onPress. So that has now detached this object 2 onPress handler event handling function. So we've got an extra function in here that we don't need. The easy solution is just to delete it. So I'm going to press the delete button, and it's going to say, are you sure you want to do it? Yes, I'm sure. But then our second attention dialog is, hey, that function contains code. And you and I know it's the default code that DrawNaCode generates because we didn't change it. So it's not terribly valuable code. But DrawNaCode doesn't necessarily know that and won't make the assumption that you're okay just having it delete it quietly. So it's going to make you choose. It's going to make you say, yes, in fact, I do want to delete everything, including the snippets inside of the function. Or as an alternative, if you have put a lot of work into that snippet, you could say keep it, and it'll move it out of that function and put it in the stack before deleting the function. In this case, we just want to delete all, so I'm going to pick delete all. This is now the stack that was in the Keynote screenshot. So we've got the button, it says play sounds. We have the onEvent handler with the default snippet in it. So let's run this. So let's save it. We're in chapter 5. I'm going to call this button sounds live. And now I want to run it. So the code, here's the code that's generated. Here's the app, play sounds, and here's the console. So if we press it and release it, what you see is two events are now generated, began and ended. And if I'm a little slower and move it, what you see is, oh boy, onPress started, and then all of these moved pixel by pixel. Events were generated as the user's finger, or in my case, well, it's my finger on my trackpad, but the mouse really glided across the button. And then it ends with an ended, like it has to. So that says the code's working. We're ready to take it to the next step. The next step was, let's load these two sounds. So that's in the action palette, and it's the second button, load sound. So I want to load chapter 5. We're in the number 6 folder, 6 button click sounds. So this is all code that you can get by downloading the chapter resources that are linked on Canvas and also in the setup chapter for the keynotes, and obviously also the link is in the book as well. But here's the two sounds that we're going to use. So I'm going to load click on, and then I'm going to do it again and load click off. Here's click off. Okay, so all of that folder navigating to get us to the stack with these two load sound script objects, object 7 and object 8. If you want to, you can move them up, like I said. That tends to look more correct to most people, although again, it's not, it doesn't make a difference at all. This now loads the two sounds. If we ran it, this is no different. No sound will play, right? You can tap it all you want. The sounds will not play. Why won't the sounds play? The sounds won't play because we haven't played the sounds. So there's a separate play sound script object right here. So we're going to play both of the sounds. There's sound 1, and I'm going to pick sound 2, click off. So now I've got two play sounds for click on and click off. Let's save it. And before I save it, just think for a second, what do you think is going to happen? All right, let's save it. There you go. So the sounds played. I hope that's what you expected, because if you look at the stack, the flow of execution is top down. So the require statement is executed, the sounds are loaded, the function is skipped, the button is created and displayed, and then click on is played, and then click off is played. What you're hearing is the sounds being played because they're still in the main stack. They're part of the execution order when the script loads. We don't want them there. We want the play sounds only to play in response to a button event. That means we need to move them into the button event handler. This is the button event handler. I'm going to select the script object, and there's a big button over here, move play sound into function. That's what we want to do. There is only one function, so there's nothing to choose here, but when our scripts get more complex, you'll want to make note of the name of the function you want to move into, or the script object ID that it is. For us, in this example, we want to move the play sounds into the function object 5. So that's also happens to be the only choice. And if you watch the stack when I do this, what you'll see is the sound jumping into, watch it over here, it'll just jump into the function. All right, so this is also was a screenshot in the keynote. This is the sounds inside of the event handler. Let's save it and see what it does. But before I do, think for a second, what do you expect? All right, let me save it. So there were no sounds, right? Hopefully that's what you expected. The sounds are no longer in the main execution thread for the script. They've been moved into a function. The function is not called when the app loads. The function is called when the button's pressed. So if you press the button now, you'll hear some sound. And it might have sounded a little bit strange because, first off, both click on and click off are played simultaneously, essentially. And they're also played twice because they're played for each event. So they play when the began event is fired, and they play again when the ended event is fired. And so if you do that quickly, what you're hearing is four sounds playing almost simultaneously. Probably not what you want, but again, that's what we've asked it to do at this stage. We don't have any logic or that tells Lua, tells Solr 2D, play click 1 if this is true, play click off if this is true. That's what the if-then logic is for that we need to add. Okay, so we need some snippets. Here's our stack. We actually have one snippet already. It's got the default event support in it, which is this little bit of code here, which is what is spitting out the description down here. So this is just here to give you an example of the syntax that you use to detect the phase. In addition to doing something that's modestly useful, it also gives you an example. The default snippets are all there to do something at least modestly useful, and then also to give you an example of the syntax that you use to work with that event to do the things you want to do. That's hopefully more than modestly useful. So I need 2 more snippets, assuming I'm going to just modify the code in this one for my particular needs. I still need a snippet that goes in between these two, and I need the snippet that's going to go after the 2 play sounds. So snippets are in the snippets palette at the bottom. I need 2 snippets, so I'm going to hit it twice. And you can see in my stack I just got 2 new snippets. I'm going to move them into the function. I'm going to do that using the button, move snippet into function that's on their settings panel. Again, there's only one function, so there's not any worry that you'll get it in the wrong function. But I'm going to do the same thing for both of them. Select the snippet, hit move snippet into function, hit OK because I've already selected the correct function. That gives us a stack that looks like this. So this is sort of a midpoint between the screenshots in the keynote that we looked at. What you've got here is snippet, play sound, snippet, snippet. So that's not what we want. We want snippet, play sound, snippet, play sound, snippet. So I'm going to move object 11 up the stack so that it is now between the 2 play sounds. So now I've got the order that I want. I've got a snippet, I've got a play sound, I've got a snippet, I've got a play sound, I've got a snippet. Now I need to put the actual logical code, Boolean code, inside of each of the snippets. And you could refer back to the keynote if you're not sure, but I'm going to start with the top snippet, object 6. This is where I need the if statement. So the syntax in Lua is the keyword if, then the Boolean test that we want. So that's if event.phase double equals began, then. So that, I mean, unless I've screwed it up already, that should be the correct syntax for the start of the if statement. The keyword if, the keyword then, and then the logical condition between those two keywords. Note that I'm using the double equal sign for equality, and if you're coming from another language where parentheses are required around the condition, this might look strange because there are no parentheses, but you could put them if you want to, but again, that would be trying to make it look like a different language, so I want to make it look like Lua, which doesn't require the parentheses. That's the top snippet. The middle snippet here, object 11, I'm going to edit. This is the else if. So this syntax here is the keyword else if, all one word, condition, event.phase, test equality, test for ended, and keyword then. So I've got two keywords, else if and then, and in between else if and then, I have the Boolean test. The test is simply asking whether or not the phase is ended. And then the last snippet, here's the one that's really easy. The last snippet is the end. We want to end the if statement, so we use the keyword end. And then just to make the stack a little bit easier to read, I'm going to change the description for each of the snippets so that when I look at the stack, I can read it a little bit more easily. So the first snippet is the if phase, I misspelled that, phase is began. And now you'll see the snippet now reads if phases began. Second snippet I'm going to rename to else if phase is ended, and that's changed the snippet to be more descriptive. And then the last snippet is just the end. If you want to be a little more detailed, you can say end the if statement, or some languages have end if statements. Lua does not, but you can say end if or end if or whatever you want to make it read the way you want it. So now we've got reading the event handler function. You can see if the phase is began, we're going to play click on. Else, if the phase is ended, we're going to play click off, end. So let's run it. And obviously, it's always good to start out with an expectation of what do I think is going to happen. And so far, it hasn't been working the way we want it to, but I think unless I have a typo in there somewhere, this will actually work. So if I click it, or press it, or tap it, I hear the two sounds, and you might be disappointed. You might think, wait a minute, that sounds like it did in the last iteration without any of the logic, and that's just because I'm not pausing. If I press the button and pause, and then release, you should hear separate click on and click off sounds. So the click on is kind of a lowering sound, and then the release is kind of a pop back up sound. And I know it's hard necessarily to see what I'm doing, but I'm going to depress it and hold it down. So it's held down. You can also see that the button has been shaded slightly to look like it's depressed. That's part of the default Draw in a Code setup. And then I'm going to release it now. And the button brighten backs up and the release sound is played. Let's peek at the source code. Here's the onEventHandler, object1 onEventHandler. This is the function that gets ran when the user presses or releases or does anything with the button. Here's the if start of the if statement, if event.phase double equals began, then. Here's the play sound. Here's the else if, event.phase double equals ended, then. Here's the second play sound, and here's the end. So we have a complete if statement here, starting with if, ending with end. In between it, we have the logic to split the flow of execution either to began or ended. Again, this is only one way to implement this type of logic in Draw in a Code. We'll use the other approach as well, lots. That is where I wanted to get to today. We'll pick up next time with a little bit more complex an example. An app that actually does something which counts up and counts down, and resets. So it's a counter app using 3 buttons and a large text display object, and we'll work through how to create that and get it to work correctly next time.